Hello friends of the net, it's Thursday, time for another API review. We have a few issues today. I think the biggest one is probably the JSON one actually. But let's start with something easier. So there was a spec that I wrote a while ago about this feature. So the spec is merged. We kind of have agreement on the general feature. And so one of the things in that spec is the attribute. Just to give a summary, that we shipped this feature in, I think, .NET Core 6 to mark platform features as experimental, or we called it preview. That worked great for platform features. That didn't work so well for library features. And so we decided that it makes the most sense to have a different attribute with a different name to allow third-party libraries, meaning libraries that don't ship in box with the platform itself, to mark APIs as being not stable, meaning they will be changing over time. So if you use it, you will get a warning, and then you get to suppress that warning, and then you can decide which API breaking changes you want to buy into. And that's the corresponding attribute. The one we shipped before was in, I want to say, runtime versioning, because it is about the runtime itself. This one we put, or I should say I put in system diagnostics, the code analysis, because that's where all the other general purpose attributes go that we expose for use, like nullability, for example, some of the linker ones as well. And so that made the most sense to me. The attribute targets is basically the same as the other attribute, like basically any API you can apply it to, plus the module, plus the assembly, to say everything in here is effectively preview. And then the only difference here is it has a diagnostic ID that is required. So it's kind of logically modeled more after obsolete attribute. That's also why there's a URL format property, which, it's URL format because the idea is that in the string it will replace it with the diagnostic ID if there is a placeholder in it. And so, yeah, unlike obsolete, diagnostic ID is required so that every basically API can have its own diagnostic ID, or I should say every group of APIs has the same diagnostic ID, so you get to suppress them all in one go rather than having to suppress every single call site, which was the problem with the original attribute for obsolete. And so, yeah, that's pretty much it. So any questions for this? Yes, exactly. So it would work similar to how the current feature works, right? If you mark an API as requires preview features, then if you use it, you get a build error. And then you have to go to the project file and say, I opt into preview features for the platform, and then the warning disappears, right? And that will be similar here, except you don't modify the project file to say, I am okay with preview features. You're basically supposed to suppress the diagnostic itself, right? So you can use no warn, you can use pragma suppressions in your source code file. So it's basically whatever. There's like, I think 3 or 4 built-in ways how you can suppress diagnostics in Roslyn. And so you pick the one that you like. But yeah, the idea is you suppress them. The only thing here is it's not an analyzer, it's going to be a compiler feature. And the reason it's going to be a compiler feature is, one, the compiler team wants it to be a compiler feature, so that's fine. They want to do the work. I'm not going to say no to that. And then the second thing is analyzers have to say upfront when they register in Roslyn what diagnostic IDs they raise. But then the problem is you can't have an open-ended set, right? So here the idea is the person applying the attribute says what diagnostic ID to use. So when your analyzer registers, it can't say, oh, here's the strings that I'm going to use, because it completely depends on what the user is doing, right? So that's just a limitation in how Roslyn analyzers work, which is why it has to be a compiler feature. But that's a detail, right? The user doesn't care whether it's a compiler warning or analyzer warning. The experience is the same. Any opinions on the name? I went with experimental rather than preview because it seems to be bad to have 2 attributes that have preview in the name. It seemed easier to say there's the notion of preview, which is for the platform, and there's the concept of experimental, which is a generic API thing that anybody can use. Adjective the end. I like it. Okay. All right. So nobody's any objections. Then that's easy. Can someone check YouTube chat? Because all I see is a white list here. So. All right. That was a nice clarification. All right. Let me just copy the thing here. Oh, that's great. Oh, yeah. Yeah, I know why. Try again.
Yes. So hopefully you can all hear us now.
Yep. Should be no.
Perfect. If people will just put in chat if everything's okay. I trust.
All right, Jason.
All right. So I guess I can take that. Can you hear me?
Yes, I
Good.
can at least.
Yeah, I mean, you are the only person that I need hear me. So
that's hard. Sorry, YouTube chat.
Right. So this proposal is not really adding new functionality. It's mostly addressing a UX concern that has been expressed from the ASP.NET Core team as they've been kind of picking up source generators and trying to use our contract customization APIs in ASP.NET Core applications themselves. Now in .NET 7, we shipped a method that lets you essentially combine multiple source generator sources via, well, a combinator method that accepts a bunch of inputs as a parameter array and gives you a new implementation of the interface that kind of does a chain resolution of each of the components, and kind of the order of arguments is important in that respect. But based on feedback that we've received, that has created a few usability issues from the perspective of ASP.NET Core, because in that case, it is typically expected that people would be using multiple configure callbacks to kind of keep adding more metadata to the JSON serializer options instance. And as such, it's not necessarily the case that you have a singular composition route where you have everything that you need and you basically just pass it into this big monolithic combine function that gives you the one resolver that your configuration needs. So basically what the ASP.NET Core people found was that this thing kind of resulted in a lot of awkward code where they would checking the resolver if it existed. If it was null, then they would insert the thing that they needed to insert. If it wasn't null, then they would call the combine method. And it basically resulted in a lot more extra code than what might have been necessary for a pretty straightforward append operation. We initially responded to that feedback by making a change to the semantics of the add context method. Now, the add context method was a method that was introduced in .NET 6. It was introduced at a time when contract customization wasn't yet a thing, and we kind of we retrofitted that method so that it had append semantics, which basically means that if a user had specified some kind of resolver configuration before, whenever you do add context, it would basically just append whatever you gave it at the end of the current resolvers that you have. Now that does introduce a small amount of breaking change, but it's not very important, we think. But most importantly, it only gives you append semantics. It doesn't give you prepend semantics. And further feedback from the ASP.NET Core team showed that essentially they need to be able to do both. They want to be able to append resolvers, and in some cases they want to prepend resolvers, because, like I said, the order of the order of chain components is important. So basically, what this proposal is It essentially pertains to having an auxiliary property in JSON serializer options that returns an iList of iJSON type info resolvers. And the idea is that the two would essentially be in sync. So if you configure one, then you would be getting equivalent responses when you try to get the other, and vice versa. And the idea behind that is that it gives users the ability to both make like prepend operations, append operations, removing elements from the chain, and more importantly, running introspection of what actually is in the chain. Because until now, it basically was just an interface, and you couldn't really introspect anything. Like you basically just took that interface at face value. So that's more or less the proposal. It doesn't really add any new functionality. It just adds, let's say, more metadata for users that are concerned with kind of making incremental changes to the configuration.
What are you going to return? What is the instance?
By default, so by default, it would return an empty list because the default of type info resolver is null.
No, I meant more like the type is a list of T, basically.
Yes. Well, no, it would essentially be so it would reflect the implementation of the converters property, which is an iList of JSON converter. Now that is a freezable iList, which means that as soon as you lock your JSON serializer options, the collections that it references become frozen, and any changes will result in exceptions.
That's an internal type, right?
Yeah.
Say again?
That's an internal type, right? They can't downcast it, right?
It is an internal type, indeed.
Yeah.
So the design guidelines say that unless you have extreme reasons, collection properties should be Git only, and people should mess with the one reference and not.
My apologies. The set was added by mistake. It should be a Git only, in fact.
Okay.
Good catch. I don't know. Are there any questions?
So I'm looking at the API usage, and if you set a type info resolver, we're going to manufacture a chain type info resolvers on top of it?
Correct.
How is the instance going to be the same then?
It wouldn't necessarily be the same.
Okay, because the API usage suggests that it's actually going to be the same reference, and that's what threw me off.
So I'm guessing you're referring to the examples that I've added at the bottom of the issue, right?
Yes. Oh, okay. So you have a type info resolver that wraps the chain type info resolvers. Okay, got it. Not the other way around. I get it now. Yeah, this pattern's followed in other serializers.
Yeah.
MVC uses the same pattern too in certain cases.
And iList has enough on it that the prepinned is achievable?
Yeah, you basically just use the insert method, and you can basically inject it at any place within the list.
I never remember what's actually on iList. I know it isn't everything on list. So.
Yeah.
So you don't really have a sample code here that says, so what happens when you assign type info resolver after you insert it or add it to the collection?
So if you assign to type info resolver, you basically nuke the chain collection. It would basically shrink to a singleton list again, which would contain just the thing you just assigned it to.
Gotcha. So you don't try to find the default one and then replace it, or you don't try to find the instance from the old value and remove it or something.
Yeah. But again, that also means that in our attempt to make these two consistent, it would be the case that you would be setting something, but then when you get it back, you wouldn't necessarily be getting the exact thing that you just set it to. You would be getting something that is equivalent to what you set it to. And there's nuance as well, like the resolver that you get from the combine method, the existing combine method, that is effectively an iList. It is a list under wraps, It's an internal implementation though, but for all intents and purposes, it is immutable. Now the list of resolvers that this is proposing, it would be in fact a mutable but freezable list. So you wouldn't want to just take that and jam it into the iList. It would need to necessarily copy the elements into a new thing that is tied to the specific JSON serializer options instance so that it can be mutated without the initial argument being mutated as well.
Yeah, that seems like a reasonable design.
I see. So you're basically saying that, you know, when you assign the property and you wouldn't nuke the collection, then getting it, you would not get the same instance back. You would get the chained one where the one you just assigned is just effectively in it.
Yes.
Gotcha. So that makes sense. So then, so I guess then, is it fair to say that that the type info resolver is more like a, you know, one way of doing it, the collection is a different way of doing it, and if you mix them, well, then you may be getting weird behaviors, but we try our best to make it consistent.
Correct, yes. But for all intents and purposes, you should be getting the same behavior from a metadata resolution perspective. Like, you might be getting different instances, but the configuration should remain the same.
Yeah, the one thing I still don't quite understand is like, you are effectively saying that for usability reasons, the combine was not as usable, and I don't quite understand why. Like,
right. So
if you support nulls here, why wouldn't that just be the same thing logically?
It is very much the same thing, but I think what we hadn't anticipated is that we expected that, you know, you'd have like one method that configures your JSON serializer options. You have all your JSON serializer context at hand, and you just pass them in nice arguments and you set it to the resolver interface. But that is not compatible with how ASP.NET Core is configuring things. They want to be able to keep appending or prepending resolvers in different stages of the configuration pipeline. And just to give you an example, in native AOT, ASP.NET Core needs to inject their own JSON serializer context that provides metadata for the problem details class, which is internal to ASP.NET Core, and users wouldn't be able to pass the schema for that unless they use reflection. So essentially what ASP.NET Core is doing currently for native AOT is that it is prepending the resolver that specifically works for these internal types in ASP.NET Core.
But isn't the, like, logically, when I look at combine here, let's say this is old and then this is new, isn't that, depending on where I put old and new, just you either append or you prepend?
I'm not sure I follow the question.
So, like, I mean, maybe I'm misunderstanding what the arguments here are, but like, I assume the combine method takes a type resolver, or is that not the case? So
Correct,
then,
yes.
yeah, so then if I want to prepend, wouldn't I just say, you know, assign the thing JSON type info resolver combine, you know, whatever this instance is, dot type resolver, and then that's my my append.
Yes.
If I chain them around, now it's a prepend. Like, isn't that effectively the same thing?
It is absolutely the same thing. The only thing that changes is that you need to type a lot more things to make that happen. You need to do a null check on the type info resolver property, and then you need to do options.typeinforesolver equals JSON type info resolver dot combine open parens options type info resolver comma your thing. So it, you know, you can absolutely do that, but I get the perspective that it's kind of a lot of code to type for something that should be kind of the basic thing that you do when you configure your ASP.NET Core application.
Yeah, I guess I get that the shape is not, like, I'm just wondering if there's tweaks we could do to make it less sucky. Like, for example, we could say combine accepts nulls and we just coalesce them, so you don't have to do the null check, for example, right?
I need to check if it is actually doing that.
So basically, let me zoom out. The reason why I'm poking, like, what I don't like, I think, is that in the current design now, you basically have two places that kind of have to be in sync, right? So we have these like weird syncing behaviors now, and I think I would prefer a model where, you know, the data that is stored isn't the same format, and there's always going to be, you know, a single source of truth, if you will.
Yeah.
And so another option, which I guess I also understand why it's shitty, is like a method that we directly add to type info resolver, like, you know, add context and, you know, I don't know, prepend context and append context, for example, right? But yeah, that has other problems. So it's, I guess I'm not in love, but I'm also not, I also don't know what to do differently, I guess.
For what it's worth, I just checked, and the combine method does tolerate null input. So scratch that on needing to do the null check.
So I don't know if this was a scenario of yours, but one of the things that we saw in MVC way back in the day is that people had cases where they actually needed to replace an existing resolver.
Right.
If everything is just kind of opaquely behind a combined resolver, it's very difficult to like dig into that, delete the thing that you don't want, and insert your replacement instead in the exact same position. Having an actual iList makes that a whole lot easier. I don't know if that's a scenario for you, but I know that
that's primarily the motivation, like full ability to introspect, because the only alternative is, you know, private reflection. Look at the implementing class and find the actual list of T that is hidden behind a field.
Yeah, that on a related note, using chained in the name is a little strange to me, because chained implies that the immediate resolver is responsible for discovering and invoking its own fallback. Whereas in this case, you literally just have a list.
Yeah,
there's no chaining per se.
I'll point a couple of other things. One, the list of JSON converter has the precise same semantics. Like a JSON converter could be a factory, and the idea again is that order is significant, and the first factory that says yes, I can convert this type wins. So it's the precise same semantics. Like order is substantial, and if users want to overrule a specific custom converter factory, they can just introspect, remove it, replace it, you know, whatever. And another piece of historical information is that when we were reviewing these APIs in .NET 7, I think it was you, Imo, that kind of pointed out, well, shouldn't this be a list of resolvers? And we kind of, we couldn't think of a use case. So we're like, no, it should just be, you know, one interface that should be the source of truth. But it turns out that that might not have been kind of the best approach here.
Yeah, so I think the other question is like, how strong do we feel that this approach is better? Like, would we go so far and basically say don't use the previous API, use the new one? Because I feel like what you said, that it's a list, that only works when people stop combining, right? Because if people combine and then add the combine stuff to the list, then well, you still have like things in between that are basically black boxes that you now have to use reflection over, right? So like you kind of want like a flat list for the whole thing, I guess, right? You don't want people to combine anymore if you want to actually be able to find stuff and replace it, for instance, right?
I mean, if I personally was writing an app, I would keep using the singular type info resolver because I like having like one composition root where everything is defined. Now I get that not everyone wants to be able to design their apps that way. So I guess the answer would be it depends on what you're trying to achieve, really. But that, of course, introduces other problems because now you have, multiple ways to achieve the same thing, and it's going to be more difficult to explain to users how these two things that are very similarly named relate to each other, and that is definitely going to introduce confusion.
Like, I mean, your example, like the reason why ASP.NET didn't like it is because they had multiple calls to the configure, right? They're presumably in different components, right? So
yeah,
if it's literally just a guy in the app, yeah, you pick the one way you want to do things, right? But if it's just, okay, the app is composing multiple components authored by different people, then ideally all these people agree, we all use the chained approach so that when the guy at the app level composes it, or when they compose, among themselves, they can always rely on that being a list, right? So as soon as you have somebody in the middle that is like you and says like, screw this, I really like my combined thing, then well, other people no longer get to like inject in the middle or replace, right? They now have to treat your thing as basically one big box, right? Which I guess could be an advantage, right? But then you might find yourself 6 months down the road of saying like, yeah, we really should deprecate this API because people should stop doing that. That's kind of why I was asking, like, how strongly do you feel about the replacement or the, you know, injecting in the middle kind of thing for what other people have been doing?
Honestly, I don't have any. You know, how do I put this? I hadn't even considered the possibility of, oh, you know, multiple owners will try to make changes to this options instance. Like that's not something that I considered a valid scenario, to be honest. But it turns out that it is a valid scenario, and if you accept that, then you know it is definitely the case that what we did ship is problematic.
Yeah, I'm curious what other people think. I mean, I'm fine, I guess, with the shape as it is. It's just always when you have two things to do things, you might find yourself in a way where that, even if you can make it well defined, which I think you have, I mean, the behavior you described makes sense. It might still be surprising depending on what people want to do, but it just might not compose well. But I guess we can also just decide to do that later if we see that people have issues with having two ways to do it.
Yeah, I kind of wish we had some of the people in ASP.NET that kind of did express this feedback to weigh into this conversation, but that's basically what they told me, that they found that this API to be very awkward when they were using it in their APIs.
Yeah, no, that one I can totally see. The other question was, like, I think Levi suggested to rename it to just type info resolvers. Like, did we say yes or did we say no? Like, I forgot what the conclusion on that one was.
I initially went with type info resolvers plural. I kind of went with adding something just to make it dissimilar enough to make people stop and think, let's say. I don't know if that makes things better or worse, to be honest.
I mean, you have this one practical downside now that because of alphabetic sorting, these properties are far away. So if you put them next to each, I mean, in IntelliSense, it probably doesn't matter because we now do suffix matches as well. So if you type into resolvers, we will show them both, right? But I feel like in documentation, other things, it almost seems like you want people to see both and then wonder, like, why are there two? Like, how do they differ? To make them actually choose the one they want, right? But
well, we have a few different levers we can pull, right? Like if we want people to use the list-based one, we can simply hide the original property, unless we think that would just be introducing difficulty for people.
Yeah, that's kind of, to me, on the same dimension as kind of obsoleting it, right? Because you basically take a stance and say, thou shalt not use the old way, right? And it seems
I mean, from my perspective, I still think the old one is the clean way to do it. But you know, I wouldn't necessarily agree that we should try to obsolete it. But
right, but then that's what I'm saying. I think you would also disagree then on hiding, presumably for the same argument, right?
Yeah.
Yeah. So then, I mean, to me, I mean, I think I would prefer it without the chained, but if you feel strongly the chained is better.
I don't have a strong opinion either way. I just, the prefix felt strange to me because of the way that these things are normally created, or because of the implication that the word chained normally gives, rather.
For what it's worth, I don't share that implication of the word chain, but my chains are mostly X509 chains, which are very, very different kinds of chains.
I mean, the converter property is just called converters as well. I guess the only difference is that there's no singular converter property to introduce confusion.
I mean, I think if I see like a plural, I kind of assume that you would walk them, right? Because I don't know what else you would do. I mean, there might be some nuance of like in the way you walk them. Right? Do you give up what first? Do you apply them all? And then I don't know, but like that to me is kind of like chaining and non-chaining doesn't really answer that either. It's a seems like you have to read the docs on that one. All right, so it seems like we're all kind of happy-ish with what we see. Then I guess. Let me leave it like this.
And we keep chained, right?
Well, I kind of just removed
no.
it, but like I
Oh.
thought that's where we were leaning, because I think Eric was like, I don't care enough.
Well, I thought Jeremy had said that. I thought Jeremy was like the only one of us who felt strongly enough, and he said like, keep it. Did I mishear you, Jeremy?
I said I didn't think that the word chained implied the notion that it's like the ASP pipeline where you have to call next yourself. I don't think that chained necessarily implies that.
So what do you think about the naming then? You like it with or without, or don't care?
I mean, this is actually one of those cases where the question is, do we want them sitting next to each other in IntelliSense because there's a distinction and we want you to see it, or we want them sitting far apart because we think that the people who want the easy way don't want to know that there's a hard way? And I don't have a user experience sense on this one of which one it would be.
I think to me the argument that they're far apart is kind of like, the problem is we don't know how they walk into it, right? And so if some people prefer one over the other, well, it might be completely random whether they find the first one or the second one first, and then they don't know that there's the other one that they would have liked more, right? So if you saw them next to each other, I guess then it's like, well, you pick the one you want, right?
Well, you end up being very confused.
Yeah, but I mean, that's kind of like, I think just the reality of like, there's two ways. Like, it's just, that's the API being honest, right? It's like...
Yeah, I mean, it does feel a little weird to have type info resolver and type info resolvers, and now the docs are going to have to say, well, if you did one and you created it with combine, then just assign the one, and if you want to do something more, then use the list. And I don't know, like, it feels like it wants more than just an S on the end, but I don't really care. Like, I kind of like anything other than type info resolvers. Type info resolver list, type info.
Interesting.
Or ordered type info resolvers, chain type info resolvers, but I don't have a lot of passion here. It just feels like it's not quite right to have the singular and the plural sitting next to each other.
Yeah, I guess for me, it's like, it would be okay to have more difference than the S. I would just prefer to be a suffix. Because I think in the docs you want them next to each other.
Yeah, that's why instead of S, I said, or instead of resolvers, I threw in resolver list.
Yeah, that would work for me too.
And then the docs would tell you when you want to care about the list versus the singular driver.
Yeah, I mean, we don't tend to use list in property names. We tend to use list in collection on types, and then just have the property names be a plural.
Yes, but we also tend not to have a singular and a plural.
Yeah,
sitting next to each other.
Maybe this would just be an exceptional case then.
That's true too.
But yeah, if everybody else likes the S,
for me, it's really just more the suffix. Like, as long as they share a prefix, I don't care about the suffixes, I guess. I
mean, I'd probably rather have it called type info resolver chain than type info resolver list, because kind of the list is redundant given that, well, the type is an IList.
Yeah, I can like that too. That would work for me.
Sure.
Ship it.
Perfect.
Yeah, that's fine.
Are you still monitoring the YouTube chat, Levi?
I am, yeah.
Okay.
Wait. See, compromises are easy. All right, then the next one, GC keep alive. Anybody context on the call?
Tobe, you had commented on this, right?
Yeah, sorry, this is hiding. So this came about because someone tried in an async method. Someone basically created an object, then awaited something, and then did a GC keep alive after the await. And if that works, it's only by accident, because the intent of GC keep alive is basically you're keeping an object reference within a method call from the point where it was used to some later point. But when you await, you leave the method. So it's not really doing what it was intended to do. Now it does cause whatever was referenced to be lifted to the state machine. But if the state machine itself goes, like nothing is rooting the state machine necessarily. So if the state machine itself goes away, it's still not keeping it alive. So at best, the use of GC keep alive like this in an async method to do something that spans and await is confusing, and at worst, it's wrong. So the intent was to have an analyzer that basically says, is this really doing what you think it's doing?
I mean, is there any reason why you would use GC keep alive for a variable that is declared before an await, and the GC keep alive is after the await? That seems it's always a bug, right?
I mean, it can work. So the problem here is there's nothing rooting the task completion source in this case. So there's nothing, like in an async method, the thing that keeps the state machine alive during an await is the thing being awaited, which is kind of mind-bending until you think about what's actually happening under the covers. Like you're hooking up a continuation to the thing being awaited, and so if the thing being awaited goes away, so too does the state machine.
Right.
So in this case, the thing being awaited is not referenced by anything else, so the whole thing gets collected. If, however, that thing had been appropriately rooted, then the GC keep alive would work. Basically, it's forcing the variable to be lifted to the state machine, and so it's sort of in tandem with the thing being awaited sticking or being rooted. That then would also cause the thing referenced here to be rooted. So you could make it work. It just isn't a guarantee unless you're like really cognizant of everything else that you're doing.
Right, because the keep alive in this case would keep the delegate alive or let's just say that becomes state 7 in the state machine. Like if state 7 gets hit, the delegate will still survive. The problem that it doesn't solve with asynchronous, well, really with the awaited code in the state machine, is the possibility that you never made it to state 7.
Correct.
Yeah, logically, the code after the await is a separate method, right? So like
a separate invocation. Possibly a separate method call.
Yeah, so which basically means logically, no, the keep alive only matters once you enter that method, right, or enter that state. So
it matters for two reasons. One, that when you enter that method call after the await completes and you kind of call back in, and two, it matters in that it will force this local to be lifted to the state machine. So as long as the state machine is alive and rooted, so too will this field be.
Oh, I see.
And so working is relying on the state machine not going away.
I see. So you're saying GC keep alive does something. It might not just do the thing you intended.
Right.
It does the thing that you want it to do as long as you root your tasks.
I mean, it's, for all intents and purposes, GC keep alive is just a non-inlineable method call.
Yeah.
And so it's forcing it to be referenced at a later point, which in the case of an async method, if that thing that's being referenced spans an await, then it's going to force it to the state machine. But it's not, the person who opened this issue thought that the GC keep alive was somehow guaranteeing that this thing was basically had a GC handle to it,
right?
And was and it doesn't,
right? And so I think you're proposing an analyzer that would be a warning,
an informational thing, basically saying like, look, this looks fishy. It's possible you're right, but more likely you meant to use a GC handle.
So you would make it informational, not warning, then?
I don't know. I get nervous about warnings. I might be too cautious.
How would they fix this with GC handle?
Well, that workaround is here in the bottom.
You'd create a GC. I mean, well, this particular repro in and of itself is, yeah, like right there. So basically you create a GC handle. So in this particular case was basically they're passing the delegate out to native code, and the native code will at some point later call that delegate back. So the delegate itself wasn't being rooted by anything, which meant the task completion source wasn't being rooted by anything, which meant the state machine wasn't being rooted by anything, and the whole thing goes away and things go haywire. So using a GC handle here, you basically root the delegate with a handle, as you would kind of typically with interop, unless you were putting it in some static field or something, and then you would free the handle after the await.
Right, but if the task wasn't rooted, then we're not guaranteed to get to the GC handle free, right?
Well, the problem here is that the delegate is referencing the task completion source. The task completion source is referencing the state machine. The delegate is expected to be used by the native method, but it needs to be kept alive in managed code.
Okay, so in this case, this is making the circular reference survive a little longer.
Right.
But wouldn't it still fail under a full GC?
No.
Okay.
Why would it fail under? I don't understand that. Why would it do that? GC handle basically creates a static root to the thing,
which lives as long as you call free, right? So
yeah,
as long as the GC handle alloc is called, then the thing is rooted.
Oh, right, because the GC handle is making the delegate rooted. The delegate is referencing the source is referencing the task is referencing the handle, and then everything.
Right.
Okay.
So my assertion is if you're using GC keep alive in an async method across an await boundary, like there's a 90% chance you really meant for it to be a GC handle.
Right. That's kind of what I was saying. I can't really think of a case where you meant that.
Right.
And so
I'm also totally fine, like in a case like this. I mean, we have, one example of someone doing something that, because of how things are documented, makes complete sense. But when you know how things actually work under the covers, it falls apart. We could hold off on actually implementing this analyzer until we found that it, more people. We saw more evidence of more people making this mistake, and we could then use the collective knowledge about that to decide in the severity level.
So I have a really silly question. The delegate is being invoked presumably on another thread, because otherwise my native method would block while the delegate is called.
Well, in this case, my native method is an asynchronous. It's like an overlapped or something.
So if task completion source.setResult triggers and the await happens to be executed synchronously, which means that the GC handle is freed while the delegate is still on the stack, what happens with regard to how or when the delegate itself actually becomes eligible for garbage collection?
I mean, once you are back in, I don't think it would matter. Once you were back in managed worlds, you've got a reference on the stack that's referencing the delegate. So that stack reference would also be keeping the delegate alive.
That's not normally how delegates work, though. Normally, delegates aren't referenced once the actual method's invoked, unless there's something really special with reverse p invoke.
No, it's referenced by the task in this case. There's a continuation on the task that's referencing the delegate.
Yeah, I learned really, really early in my .NET career that if you're passing a delegate into a p invoke, save it in a static read only. Otherwise, you're just shooting yourself in the foot. The delegates get collected, but the return stub doesn't.
But the task is no longer reachable, right? Because once the task fires its continuations, no one's referencing the task anymore.
The task is referenced by the state machine.
For some reason, I thought that reference got cleared out once the actual await was hit because it was no longer needed.
Yes, but then it's on the stack.
I don't trust that at all.
No,
that seems like an implementation detail.
Once you're back, you're inside of this I don't think it is. I mean, I have to work it out looking at the actual paper, but there will be a strong reference to the delegate.
Okay.
Well, there will certainly be a strong reference to the delegate until the GC handle free call is made. You're asking
Yes.
what happens if you're inside the method call referenced by the delegate when the GC handle to the delegate is freed?
Right, because my understanding of delegate invocation, unless reverse p invoke is its own weird beast, is that delegates are no longer strongly referenced within the invocation itself.
How is that different than just create a delegate to a method and invoke the delegate?
Because I don't know if reverse p invoke is relying on any type of native cleanup as it unwinds without maintaining its own strong reference to the delegate.
How could you ever have a reverse p invoke be successful unless the delegate was in a permanently rooted thing?
Because I think that's what you're expected to do. Like have the delegate strongly referenced from whoever called the reverse p invoke in the first place, or like Jeremy
You are,
said,
but that's what this is doing.
But the strong reference might go away while the delegate's being invoked. That's my concern.
But you're back in manage world while that's happening. I guess how could you ever have, like, there are basically two cases to handle with. You've got a delegate that you will use forever in your process and it's in a static read only, or something else that will itself keep it alive forever. Or you've got a case where the delegate is per operation. And if it's per operation, how would that ever work if releasing the strong reference to it as part of invoking it invalidated in some way?
Because honestly, I've never actually seen this scenario in any of the code I've ever written. Every single asynchronous delegate invocation, reverse p invoke, whatever nonsense I've ever used, always took a state object in addition to the function pointer, which meant that I could wrap whatever I needed to do in the state object itself, and then use a static read-only delegate and just keep passing that in over and over and over again. Like it literally just became a non-issue.
So for reverse p invoke, there used to be a bug in the JIT that was fixed in like .NET Core 3.1, where if you didn't keep alive your delegate across the p invoke boundary, the JIT itself would not keep it alive, and it could be collected before the callback actually occurred. Like while native was executing, the GC would collect it, even though it was part of the single p invoke call. There's then the other consideration of if you pass a delegate into a p invoke and it's a long-standing delegate, such as for WinForms, you have to cache it in a field, or it could be collected. In either case, if the delegate is collected before native calls, before native does the reverse p invoke to call back into managed, then you can end up with a fault because the method, the underlying pointer can be collected, but otherwise it shouldn't be an issue.
Right, that's not the case we're talking about here. The case we're talking about is it's already invoked the delegate, and once the delegate is invoked, Levi's asking what happens if you then free the GC handle that was keeping that delegate alive.
I believe the GC cannot free the delegate while the delegate method body is executing itself, because the method body would then be collected. I believe delegates are special in that they directly reference the managed method and they prevent things like assembly unload. Whereas a function pointer or another thing would not. And so you shouldn't have the issue. So unlike calling an instance method where this could be freed while you're executing the instance method, a delegate, I do not believe, is freeable while the delegate invoke is actually being executed itself.
Well, a delegate is just this object reference and a function pointer. Like no one's talking about freeing the method itself. We're just talking about freeing the object that is that tuple.
So
right, but
talking about freeing the handle, a GC handle to it.
Yeah. And then allowing the tuple itself to become collectible.
Right, but while the delegate is executing, I don't believe it is collectible, because that would then allow the assembly load context to become unloadable, which means that the memory that was allocated for the method body could then be freed.
The method body doesn't belong to the delegate, though, and the method body belongs to whatever assembly it was defined in.
Right,
Yeah.
but the delegate holds a strong reference that keeps it from being unloaded.
We're also in the weeds here, and it's largely
Yeah.
irrelevant to this
Yeah.
particular case. It doesn't matter whether the GC alloc was to the delegate or to something holding on to the delegate. The point is with GC keep alive, it's definitely doing the wrong thing, and you can use a GC handle.alloc to do the right thing. I would be incredibly surprised if GC handle.free on the delegate in a reverse p-invoke was a problem. If it is, I think that's a bug that would need to be fixed. But it could be a GC handle to an object that references the delegate too. Like, I mean,
I was about to ask, like, it seems like the analyzer or the issue that the analyzer is raising would be true no matter what the behavior here would be, right?
Yeah, we're talking about mitigations at this point. Like,
Yeah.
what do we recommend that people do? And
I guess
like
that's fair.
I'm very strongly in Jeremy's camp, which is like static read only, assign the delegate, and just let app domain unload handle it.
So you're just
Like that-
objecting to the GC handle approach. You're basically saying you should root the delegate.
You should root the delegate, yeah.
this is rooting the delegate.
I mean, like, you should root it statically within the app domain, because like this, a native method that takes a delegate without a state pointer is, to me, immediately suspicious.
I mean, obviously they exist.
They do, but like you can't easily call them from like C or C++, for instance. Like it becomes very weird at that point.
It's just a stateless function.
Sure, and if it's stateless, then why can't you just point to a static method and call it a day?
Because in the managed world, it has state. You're creating a delegate in order to have state associated with it.
Yeah, but why is the managed world different than C and C++ here, where you would not be able to provide state?
Because whoever
Because you have
defined the native method only accepted a function pointer with no arguments, and you want to be able to call it and have stuff and have it be usable. If you're asking why is the method defined that way, I have no earthly idea. I didn't define it that way.
I'm saying in practice, like in all of the like frameworks and services I've written, I've never seen a method like that, like in a production library.
I mean, this could be like a logging callback that they assume is doing static, and you're doing instance because
Sure.
you're participating in the iLogger ecosystem, and this logger is attached to some pipelines. Like there I can see reasons, and this could just be reductio of you have the native objects version of a state. So this would be like, you know, the SSL read callback of whenever you're reading memory, how do I ask you for a buffer? It's not going to accept a local state object. It's you give me a function pointer that knows how to deal with this. And that's what we're doing here. So the problem with my, you know, what I've learned of save it to a static read only is if you do want the delegate where it's bound to an instance instead of it's a static delegate, then you really don't want to, there's not a good way of doing that. I mean, you can have a list of all the delegates you've ever used, but that becomes weird.
So
I think Steve's suggestion here is fine. If we wanted to also have a fixer identify the same thing and suggest moving it to a static read only, that would also be reasonable. But this fix seems to be the general fix, even though it involves types we don't want people to generally use.
I'm not sure if fixer buys you much. I think like this is an example where you just point to documentation, right? And I think we're just contending on like what the recommendation would be, but even if you would know what it is, like I don't know that you could provide a fixer easily for that. So I would almost say it's a red herring. Like once we document it, like I think we can have an argument over what the documentation page says for this diagnostic. But I think
if this is a warning that just goes to docs, then yeah, that's an open-ended debate. I was assuming that he wanted a fixer since he had to change this code into this code.
Well, it's
if
known
we don't have a fixer, I'm
workarounds.
okay.
I think the
Fair enough.
problem is I'm not sure you can do it in general case. So then I guess reliability is the category. Severity would be info for now until we know that it's an actual. I mean, to me, the only reason I would bump it to warning is like info is basically you only see it if you if you care to look, right? So that if we think it's a high chance of being a bug, then
we could do warning. That's fine. Again, I'm also happy to say it's warning, but this isn't the top of our priority list. We've heard of one case of someone making this mistake. I haven't searched to see how many times people do. Basically, this issue was opened. We basically say it's not a bug. There's a mistake here. Should we have an analyzer that
that's fair.
flags said mistakes?
By the way, like just out of my own curiosity, like GC keep alive, is this method specialized at all? Or is it just the fact that there is a method call is what usually triggers the behavior that GC keep alive triggers?
The JIT special case is it for optimization reasons. But if you look at full framework literally, it's just an empty method with a no inline attribute.
Yeah, that's what I thought. So I thought it's just the fact that you call a method and pass an object to it that roots the object, right?
Yeah.
Yeah, I feel like the JIT knows it doesn't need to call it, but needs to sprinkle some metadata that says the object has to live until at least this long, so it can't unroot it if it any earlier than this if it inlines it. But
gotcha.
Yeah,
it's
So core avoids the method call.
Yeah, it avoids the cost of pushing another method frame on.
But I think Steve though made a really compelling argument for why this should be warning. Like you clearly wrote code because you knew that your code was potentially going to encounter this problem, but the code that you wrote to work around the problem doesn't do what you think it does.
All right, then just update this one here.
And then separately, I would personally love to know the answer around the safety of the whole reverse p invoke, and upon invocation of the delegate, it being the only thing keeping that delegate, the GC handle to that delegate. It makes me sad if that's actually a problem.
So is it fair to say the question would be, when a reverse p invoke is called, is the delegate rooted? Is that the question? Or does the delegate remain rooted while it's executed?
Yeah. Does the delegate remain rooted while it's executed, basically, is the question. And if it doesn't, is that a problem? I don't know what the problem would be.
I kind of agree with Levi that it doesn't seem like, generally speaking, there should be a problem, because you would not, like, the underlying metadata for the method would be rooted by other means, right? Because you haven't.
Well, so I think Levi was saying it might be a problem.
No, I'm saying, like, I think generally speaking, it would be safe for the runtime to collect the delegate. It's just for this particular case, it wouldn't be good because it's a reverse p invoke. But like, so there should be that basically, I think the belief is there is no such guarantee that would always root the delegate, which is what Tanner was suggesting, because in the general case, it's fine. Like, the method wouldn't be deallocated while it's being executed, right? Because it's completely orthogonal to the delegate object itself. So I suspect that might be why it's generally not rooted.
I just posted in chat in a regular delegate invocation. Like if you look at the actual assembly that's generated, there is a tail call directly into what the delegate. There is potential for a tail call directly into what the delegate represents, which means like it's eligible for GC at that point. Again, I don't know how reverse p invoke works there, but with regular invocation,
even if that were the case, what would be the problem for reverse p invoke?
Because reverse p invoke clearly needs to do some bookkeeping with regard to how it gets back into the runtime, and I don't know if it needs to do that bookkeeping in both directions. Like as it's unwinding, does it need to do more bookkeeping that would mandate keeping the delegate alive? I simply don't know the answer to that.
So basically, you would say it would potentially AV in the cleanup after the delegate executed because the delegate got deallocated while the code was running and before the cleanup was triggered?
I mean, I would hope if that was the case, the reverse p invoke infrastructure was keeping the delegate alive itself.
Well, why would it have to? Because the caller is already promising to keep the delegate alive for the duration of the reverse P invoke. Why would
No, it's
reverse P
not.
invoke ever have to
Wait,
be resolved?
why do you say it? Where do you say that promise is coming from? Who promised that?
Because that's what the gc.keepalive was for on the delegate in the first place.
No, it was to keep it, and it was to keep it until you got back into the code and it was used.
No, because it
was to keep it alive during. It was to keep it alive until the delegate was invoked, not necessarily through its lifetime of being invoked.
I bet the reverse P invoke authors never considered that a valid scenario, but you would need to talk to them specifically.
The only time I've ever seen it be a problem is when you're assigning something as a callback, and so it's you've P invoked into a thing, passing the delegate of call this later whenever you trigger your own thing to trigger a callback. As far as the runtime's concerned, no one cares about this object anymore. It's now subject to GC.
Right. I would hope this was like a key consideration for folks working on reverse P invoke. You route the delegate via GC handle. You pass you pass it off to native. Native later calls it back, and the callback frees it. That's the only place it could free it.
I think the later is the part that we're getting hung up on, because most of the scenarios that I've seen that involve creating on the fly a delegate and passing it in expect within that same thread the native code to synchronously reverse P invoke into you, which means that the topmost caller who has the GC keep alive is already doing the right thing there. The scenario that you're talking about is asynchronous method invocation, and I have never once seen asynchronous method invocation that does not take a state object as a parameter. Every single scenario I've ever seen where native code asynchronously does a reverse P invoke expects to take takes in as a parameter a function pointer and an int pointer state object, which means that when we call it, we pass in a static read-only delegate and then some random GC handle for the state object, which we then unwrap into whatever we want to work with.
I've definitely seen global logging callback functions and libraries, and that would be an asynchronous callback with no object.
Mm-hmm. But they expect you to have a single implementation, though, I expect, as opposed to something that is varied based on context.
I mean, they expect that the function pointer that they invoke will not crash.
Right.
That's the extent of the expectation. The problem is when a garbage collected thing and a non-garbage collected thing are interacting, it gets special.
Yeah.
All right. So who's on hook for this one? Carlos, is he on the call? Probably not, right? Can anybody else talk to this?
I could talk to it. Although I haven't actually seen this one in a while. So this is, if you have so we have a general rule that in a task returning method, actually, hold on, let me just make sure I get the right direction here. Throw inside the method return does. Yeah, right. Okay. So we have a general rule that methods that return task should marshal any exception that is quote quote thrown out of the operation as part of the return task. You generally don't want exceptions to be thrown synchronously out of an async method because the caller typically in some situations can't deal with that. If you're just awaiting the results of an async method, it's indistinguishable. But if you did like method.continue with or task.whenAll method A comma method B, there's a significant difference between whether the exception emerges synchronously from the method call or whether it comes out as part of the return task. So we generally say that other than for argument validation, everything should be wrapped into the return task. And that means that if you have a method that is returning a task that's not async, which will automatically do that wrapping for you, and you're throwing some exception, you should probably instead be returning task.fromException with that exception object. So that the exception comes out effectively asynchronously rather than synchronously. And so this is proposing to flag places where the body of the task return, the non-async task returning method is throwing non-argument exceptions and saying, whoa there, you probably should be doing return task.from exception instead. Now, that's noble. It is incomplete because there are plenty of places exceptions could synchronously emerge. Any method you call could itself throw an exception. So the only thing this would really be able to flag are places where the method itself is doing throw. And you'd recommend replacing that throw with a return task.from exception.
So I guess I missed the part where we're okay with argument exceptions, but we think like the embedded operation exception should be different from that.
So we basically say that for usage errors where you make a mistake in how you're calling the method, you're passing in a wrong argument. That's typically something that you could have fixed at basically development time. You could have discovered, you're basically using the thing wrong.
I see.
This method doesn't allow -1 and you passed -1. It's something that you should have been able to catch 100% of the time deterministically, waving my hands. So we basically say, all right, well, those are okay to come out synchronously because you want the developer to know about it immediately, and it's just a bug.
Basically, the idea is because if you don't write a catch handler, if the way to deal with it is by editing code rather than writing a catch statement, then yes, that's different. Yeah, that makes sense.
And so we basically, for better or worse, a decade ago, we basically said, all right, there's a special category of argument exceptions that we're going to basically say is okay and everything else is not.
Yeah. And you're saying the analyzer is cute, but it doesn't handle like you call a method and that method throws, right?
Right, exactly. So there's probably some value to this, but it's certainly not foolproof.
Yeah, so we had started talking about this on Tuesday, but decided we needed Steve, so I didn't annotate it as we talked about it, which brings up, so Emo, if we mark something as needs work and then it immediately comes back as ready for review, does it go to the top of the list or the bottom of the list? Since you changed the sorting based on when the label was applied.
It should be, because it's sorted by, in ascending order, it would go to the bottom of the list, yeah.
Okay, so if we bounce something as needs work, it goes to the end of the list.
Yeah, within the same milestone, but yeah.
Yeah.
We could mark it as blocking so that it comes back to the top.
Sure.
That's one way to
I
do
was
it.
just asking since we changed the sort. Because I think that what they had in the after, like they ended up confusing me. Because, yeah, so they have in async value task, my method async, that should not do await from exception.
Correct, that's bogus.
That should be throw.
Yeah.
Because if you're inside an async method, throw is from exception.
Yeah, this analyzer should not be doing anything with async methods.
And once it's in the async method, you shouldn't be throwing argument exceptions because those should have been thrown elsewhere.
Right,
Granted,
although I don't think that's
say don't do this because if you wrote public async, you're already screwed. But
right, I didn't think that was the purpose of this particular analyzer. But if it is, yeah, there'd be a separate diagnostic code that was like, rather than wrap, you explicitly shouldn't be wrapping. But right. This particular analyzer shouldn't even shouldn't be looking at async methods at all.
Right. So so on the basis that the analyzer is looking for throws that are not usage errors, which is what we wrote in the framework design guidelines, where now we get the infinite discussion of what's a usage error and what isn't. So yes, so only task like returning things that are not themselves async state machines. They should only be throwing usage errors.
So what I don't understand, like we said, we don't do anything for async methods, but isn't the problem there the same? Because basically, if you have any throw before the first await, like isn't
if
the
the keyword says async, the entire thing is inside a task already.
Yeah, if you use the async keyword on a method, the entire body of the method is wrapped in a try block. So any exception, regardless of where it is, gets stored into the return task.
Gotcha.
Don't we already have an analyzer for that though, saying like, hey, you're throwing argument exception within an async method, you should really like unwrap it here?
I don't think so. We might have one proposed, but I don't think we have one implemented.
It seems like a viable second, sibling.
Yeah, it's the
analyzer
other
of this.
direction.
Yeah, exactly. Yeah.
I think we reviewed and approved that analyzer last week when Mo and Steven were out, or maybe that was Tuesday.
Cool. Yeah, both directions are valid.
But the other direction is more complete, right? Because there's no other cases really, right?
Sorry, which direction are you talking about now, Ema?
So the not this one, the other direction, right? The analyzer for the other direction would basically catch all the cases, because you just look at saying oh, it's an async method. Any sort of like argument validation you have, you should extract that out, right? So you would that would catch it. Or am I missing something? I guess it wouldn't, because if you use an exception builder, we wouldn't know that it's an exception, right?
Right. They both have the same issue of you call something else. We're not doing inter-method analysis.
Yeah.
Right. Now the interesting question there is invalid operation exception, which is, I believe, saying that the object or that you've called a method that is not appropriate to the state of the object. One can have a world of debate of whether that's a usage error or a program error.
We
So
have historically said it is
bad
not. We've
example.
historically said that it is not a quote usage error. That basically, it could be, but in general, you can't guarantee statically. Like for 99.9% of argument exceptions, you can look at the call site, and know that you made a mistake or you didn't.
Right,
That's
but in like
not
the JSON DOM things, we have what data type does this represent? And it's like, oh, this represents a string, and then you say, great, now give me the value as an int 32. That'll throw invalid operation exception. I'm not a number. I'm a free man. So sometimes invalid operation exception is something that you should have been able to check against, and I think sometimes
Yes, it's just frequently not.
Sure, but
Sorry.
we would be. Then does that mean that we're formalizing argument exception is the one true like preconditioned thing that everybody should throw synchronously, and everything else is async?
We tried to formalize this 13 years ago, and then we tried to formalize it as part of the design guidelines that Jeremy wrote for volume 3 of the Framework Design Guidelines book. We say the same thing in our MSDN, or whatever it's called now, documentation, that argument exceptions are special. But to your point, Levi, we don't have anything. We don't have any analyzers today. That's what we're talking about now. That would formalize it in tooling. We could say we don't want to, that our loosey-goosey heuristics here are something that we care about for our own stuff for consistency, but we don't need to push out more broadly. Or we could say, we keep a very low severity on them, or whatever. That certainly the analyzer that this is talking about, that this issue is talking about, I think is more important. There are a lot more dangers that come with throwing the exceptions out synchronously than come from throwing too much out they come with catching too much asynchronously.
Sure.
Yeah,
because I'm looking through some of our networking stack, and we throw, even from async methods like on HTTP client, we throw at least object dispose exception synchronously. So we might want to consider that in addition to argument exception,
or fix those. Object dispose exception is another one of those, like, you're using this object. I don't know. It's weird.
Our soft
You're using
usage
this object
of usage
in a way that
errors
was never
is
intended to be used.
Our the soft definition in Framework Design Guidelines is something that someone should be changing their code for because they've written a program that is wrong, versus a runtime error is things like you wanted to go create this file, but somebody has it already open and locked. And it's like, well, one of these is your program is wrong, and the other one is like life happens. And everything in between those gets fuzzy. For what it's worth, Framework Design Guidelines says invalid operation exception is a usage error.
So like my mental model in general is for these is basically, let's say you had an async method and you await something and then you call something else, right? Mm-hmm. So at that point, that no matter what exception emerges from that second thing, it is always going to be wrapped in the return task. So what are the possible exceptions that could be? That should never be an argument exception. It could be pretty much anything else, but should never be an argument exception because you shouldn't be using these methods incorrectly. Whereas it could be an invalid operation exception, it could be an object disposed exception if there was some runtime condition that caused you to dispose something erroneously. But from a just pure, a pure theoretical development perspective, you should have been able to stamp out all the argument exceptions at development time. Same reason we say don't catch argument exception, basically. So to your point, Levi, I think those cases where we're throwing an object disposed exception synchronously out of an async method is arguably a bug.
Okay.
Do you think it is? So you don't think it would be a usage error of basically you've called dispose, then you've invoked a thing off of that method as like the next direct 2 lines of code, like that?
Well, it is a usage error, but it's not a usage error of that specific method. You haven't used that method incorrectly. It's you used something else incorrectly before using this.
Yeah, like there was a precondition check that you should have done that failed, but that precondition check isn't necessarily, like Stephen mentioned earlier, something you can tell by looking at the call site.
Fair enough, because I assume that the object disposed exception throw was basically saying anything that you would write in the initial validation block of a method is therefore a usage error, right? So you'd have your argument validation and your object disposed state check, and those are going to be before you do any real work. And so it's like, well, this is all the preamble, so the preamble is all usage errors.
I haven't thought of it that way, although I can totally see that perspective. But once you're checking state beyond that which was just passed in to use the method, I don't think of those as being usage errors, because they're not at they're not at the direct control of the caller.
Fair enough.
But we can also think of object disposed exception. I mean, there are lots of places where we think of disposals being separate, like all the work we did with nullable annotations. There are a bunch of places where annotations are technically wrong after an object has been disposed. And we basically said, well, we don't care about that case because it was a you shouldn't be touching that object after it's been disposed. That's your bad. Mm-hmm. So we can also basically say that object disposed exceptions similarly are, why the heck are you touching this object? You told us to free it. That's on you. All rules are out the window.
Yeah, I mean, so really because the only reason I think that it's worth discussing here is so that when the initial proposal comes up, like it's going to need the list of conditions where it doesn't warn that you're doing it wrong. And so is that anything that's derived from argument exception plus object disposed exception plus debatably not supported exception and invalid operation exception? I'm saying debatably because they're listed specifically in the usage error section of framework design guidelines.
I mean, we could certainly have a
we could say we have no opinion of ODE and IOE.
Right.
Like,
we can have a neutral
NNN.
list that doesn't fire on either of the rules.
Right. Then that's yeah. So that's I think what I'm moving or suggesting for invalid operation and object disposed is we won't tell you move this in and we won't tell you move this out.
I get it for object disposed. I think this analyzer would lose a lot of teeth if you included an invalid operation exception.
Fair enough. I think that's probably just a lot of people using invalid operation exception for reasons other than what it says it's for.
Well, what are the teeth that this analyzer gives you?
Preventing you from writing a method in a way that will be difficult for it to be consumed other than via using a wait immediately. So if you call my method async.continuewith, or task dot wait all, or when all my method async, comma my method 2 async, comma my method 3 async, right? Whether the exception emerges synchronously or asynchronously impacts whether the other work is kicked off.
Right, because you can't chain the other work at that point.
Right.
Okay.
And in the other direction, it's don't create state machines when you're just gonna say, don't pass me the literal null, buddy.
Yeah, the other one is it's certainly more subtle. It's like, and it often happens if you let's say you have two methods that are related to each other, like you got a client server or something, in your process, and you launch them both, and then you wait on them. Well, if one of them failed immediately because it was an argument exception, but you don't find out about that because it's trapped in the return task, and now you're waiting for both the client and server, and it will never complete because one of them immediately failed without connecting to the other or whatever. But it's a lot more subtle.
Okay. So yeah, if this group is content on saying like we very much special case argument exception, then that seems fine. I just want that to be an explicit statement, because we are kind of, drawing a line in the sand and saying these are special cased.
Yeah, so I think for this rule in particular, we're special casing it simply just not by warning.
Yeah.
Right. So in the other rule, the one going the opposite direction, it's more of an assertion that we care that argument exception is special, because we're saying you should take an explicit action to churn your code to do something special for these exceptions here. But in this case, we're not doing anything with argument exception. We're not warning you about it. The special case is we don't issue diagnostics, and we suppress it if we see that it was an argument exception, which I think is, we have more leeway there.
Yeah, I mean, I think especially with us having floated, so most of the argument exception, many common argument exceptions are now going to be done through a helper, and object exposed exception is now commonly done through a helper. So I think that says that those, basically we just would not teach this analyzer about those patterns, and then they fall through as like, yep, you didn't do anything wrong.
I mean, the analyzer could learn about things like does not return attribute, right?
Sure.
Yeah.
Although, I mean, it becomes more complicated if you're talking about calling something that might throw, because then it's not return task.from exception. Then it's wrapping that method call with a try catch, where the catch block does return try task.from exception, which is a more convoluted thing. But yes, we could do that. Of course, then we'd have to be careful about, someone doing debug.fail and recommending they wrap it in a try catch.
So then, where do we stand? Useful? Meh?
I think it's useful, but I want us to be explicit about why it's drawing this line in the sand. It sounds like Steve said earlier, I think you use the term loosey-goosey. As long as we formalize it and say like this is the pattern going forward, then that seems fine. This is a forcing function to formalize that pattern, right?
I think it's less loosey-goosey and more about like what do we observe people do in the wild, right? And try to like make it useful to people. Because our exception hierarchy is kind of messed up, right? So it's not.
I think it's worth adding. We can start small too. Like we can have as large a list we want of an allow list, and then where we don't warn. We could include argument exception. We could include invalid operation exception if we think it's a problem zone. We could include object disposed exception. But then when you do throw a new format exception, we say, no, that should be returned task.from exception.
Yeah.
This might be one where we run it over runtime and ASP.NET Core and WinForms and wherever else, and basically see what pops and tune it that way.
Yeah. That seems reasonable. Would you still put this under reliability instead of something like design?
I think it will be more design, right? I don't think reliability is the right category.
Seems like I don't know. It's a gray area.
Yeah, I mean the category description for design is supporting adherence to the framework design guidelines, and we have a framework design guideline now that says argument exception is outside the state machine, and file not found exception is inside the state machine.
But it's there for reliability reasons.
Fair enough.
Yeah. It helps people have better success using your library and write less buggy code, presumably.
Yeah, that's the intent, is to make. Now, I think over time, this has gotten less important, because if you are awaiting, you just say await foo async, like it's indistinguishable other than in some diagnostics and stack trace and whatnot, what you did, whether you wrapped it in a task or threw it directly. It's only when you do something else, and because async await has become the 99 and is increasingly the 99.999% case, at some point this stops mattering. But
well, for value task, like, isn't there an analyzer that says you have a value task and you're not immediately awaiting it? What are you doing?
It's close to that. It says if you're not immediately awaiting the result, it tries to check via some data flow that you do await it and only once.
Or return it and never awaited it or inspected it. Because I think it allows you to invoke the method that creates the value task, then do a bunch of, maybe you're doing a bunch of cleanup, or this is a potentially long-running operation, so you've kicked off the thing on a remote machine, you do your local piece, and now you await joining, or it could be you did your bookkeeping and now you're returning to your caller. And so those are both fine for value task, because you never inspected it. Inspecting it is what makes it dangerous.
And there are lots of holes in that analyzer in both directions. It's just there to try and catch the 90% case.
But yeah, I was looking at the categories with their description. I think reliability fits, because design, if it's design, somebody might be like, you're just being opinionated, and this is reliability of you may be breaking some application because you're not following the rules. Well, because design's mostly about the shapes of public members, and because that's most of what FDG is concerned about. The reason that this made it into FDG, and it has a description of like, we're butting into your implementation details, and that's because these are effects that are externally visible for how your method operates. And that if you're not playing in the same system everybody else is, then they may make a whole lot of bad assumptions. So.
Okay.
Seems good to me.
So did I forget anything in the notes that we wanted to record for Prosperity, or is that it?
Oh, that's good.
All right, then.
Yeah, hopefully.
Actually, one thing is we should clarify. Sorry, email.
That it does not apply to async.
That it does not apply to async
methods.
methods. The examples provided were wrong.
Yeah. I was about to say, hopefully the implementer knows it doesn't apply to async state machine methods.
All right. Shuffle. Every day I'm shuffling.
Right. So in .NET 7, we approved and exposed the API of vector shuffle. That notably is a cross-platform hardware intrinsic, and so it has deterministic behavior across platforms. There are some cases, notably in our own code, but also in some customer code, where they're basically doing the relevant checks or masking ahead of time to know that basically all of the inputs are well formed, but where the indices are therefore not a constant, and so the JIT can't do the analysis itself to basically better optimize the code. And so the proposal is to expose an API, shuffle unsafe, which directly correlates to the underlying hardware intrinsic for a given platform and doesn't do the additional masking. So effectively, if the indices are inbounds, it is well defined and well behaved, same as shuffle. But if the indices are out of bounds, you no longer get the deterministic behavior. You now get platform specific behavior. And hence using the unsafe suffix like we've done for other similar APIs where the behavior is non-deterministic for the cross-platform variant.
Does the cross-platform variant still have a behavior? Sorry, I guess do all platforms have a behavior where, like, if the high bit is set, then some very specific sentinel value gets shoved in the vector?
So that's where it is. That's where it differs between platforms. So shuffle today, what we defined is that anything out of range selects the value 0, and that's the sentinel value inserted. What happens in practice is that on x86 and x64 hardware, they treat most out of bound indices as masked. So if you've got vector 128 of byte, you have up to 16 for your indices, and if you're at or above 16, it will actually mask and only take the lowest 4 bits or whatever. And for x86 and x64, it only does the zeroing behavior if you have the most significant bit set, like you said. However, for ARM64, they don't mask. They treat any out of range value as 0. Other platforms may themselves have other behavior. So the unsafe API, it's only going to have the guarantee of inbounds indices are well behaved, out of bounds will be platform specific. And we'll have a remarks in the XML docs that will explain, like, here's the x86, here's the ARM, and other platforms may themselves have their own behavior, so consult the architecture docs.
So Tanner, in our existing vector 128 shuffle, are we paying, and the indices aren't seen at the call sign as consts, are we paying an extra perf penalty for doing that masking on certain platforms to ensure consistent behavior?
Yes.
Okay. So we would basically say, if you know your indices are correct, we'd basically tell people always use unsafe.
Right. Notably for ARM64, there's no cost. For x86 and x64, there is a cost because we have to normalize everything to have that high bit set. It's not expensive. It's like one extra instruction, but it is one extra instruction.
And I assume we don't pay that extra instruction if the JIT can see all of the indices as consts.
Correct. Provided we see it as constant, we do the right thing and we optimize it out. The issue is that there's complex code. For example, in the probabilistic table logic that you reviewed yesterday, where the masking is happening, the relevant masking to ensure the indices or inbounds is happening implicitly, potentially higher up or across a method call boundary. And so it becomes quite expensive for the JIT to do the full control flow analysis to determine that.
That makes sense.
Notably, this should be for all of the vector types, not just vector 128. So it should be vector 64, 128, 256, and 512.
What does
They all
unsafe-
have. Oh, sorry, go ahead, Levi.
I was going to ask, like, what does shuffle unsafe mean on vector 64 on like x86, x64? It just uses like the register or something?
No, the registers are deprecated and not recommended for use because they use the by87 FPU stack. So vector 64 on x86 hardware just implements a software fallback. If there was ever a reason to do so, we could emulate that using vector 128, much as we do for system numerics vector 2, where we basically load and store from memory as 64 bits, but then do 128-bit ops behind the scenes, ignoring the higher bits. But we don't have a reason to do that today. And users aren't expected to be calling these types if is hardware accelerated says false.
Sure. So it sounds like shuffle unsafe on an x86 or x64 platform or vector 64 would then just be, we're going to do the absolute fastest thing we possibly can, assuming that the indices are in bounds, and our own fallback logic might just do random weird stuff if the indices are out of bounds.
Right. We'll likely just implement it as the same as shuffle, just for simplicity purposes, but we won't guarantee a behavior for out of bounds indices.
Steve, you had a question, sorry.
I did, but I totally forgot what it was.
So do we already have the pattern where we have unsafe intrinsics, or is that a new thing?
No, that's an existing pattern. So we have, for example, load and then load unsafe. We have create scalar and create scalar unsafe. The difference is that create scalar sets the 0th element and then zeros all upper bits, whereas create scalar unsafe sets the 0th element and leaves the upper bits undefined. So it likewise allows us to kind of optimize out by leaving in some non-deterministic behavior.
Yeah, most of the other unsafe APIs on Vector have to do with type safety unsafeness or memory safety unsafeness. This isn't quite that, but I assume because it's platform defined, we could say if you pass something out of bounds, you could potentially get type unsafe or memory unsafe behavior because you're violating the precondition for this API.
Right. We'd still make it like we wouldn't allow it to cause things like we wouldn't ever allow something like using the indices to actually access from memory or something like that, which would be, a dangerous security hole. So like this won't cause an AV or anything. But we will generally not guarantee what behavior will what value you will get in the result.
Yeah. As your security advisor, I'm actually okay with you like causing AVs here if someone calls an unsafe method and passes a bad parameter. That's why it's called unsafe. But
if
sure.
The vector 64 is software-y, then do we even need the unsafe? But then I'm going to guess that the answer is
so it's software,
like 32-bit ARM.
So it's software-y on x86 hardware and x64 hardware, for those who want to differentiate. It is accelerated on ARM64, and it is accelerated on it is acceleratable on ARM32 if a given runtime felt the desire to go and add that support.
Okay, just making sure that we have a reason to add it. Like there will be a distinction somewhere, because if it was our same software everywhere, then
there are platforms that do support it being accelerated and executing direct hardware instructions today.
Is this only relevant for byte?
So it's technically relevant to everything. However, most of the other implementation I guess what you're asking is, should this be exposed for everything? And the answer is yes, it should be supported for all 10 or I guess 12 generic types. The reason that Miha only proposed it for byte is because that was their immediate need, and because when you can't determine the values are constant, most of it falls back to a byte implementation anyways.
Yeah, notably, all the cases in runtime where we use workarounds for this, so like writing our own helpers that do the platform check, they're all using byte, and they're all only using the vector 128. Since, for example, for the vector 256, only AVX2 does that. So all the implementations that do that sort of thing right now in runtime, they just call AVX2.shuffle. So for parity, like, I'm fine with adding it on other vector types, right? But we haven't seen any need for other types.
And that's
like,
fine. I wanted to understand, like, and sometimes we basically say, yeah, we'll go ahead and add these, but we sort of pre-approve if there's a need for other types, which we could do here as well. I don't want to be in the business of adding 64 new overloads just because, but I was interested in understanding why byte was special.
I mean, do we have any other ones where we just take T?
We have typically avoided taking T for these hardware intrinsic APIs under the premise that it makes it complicated to know whether a given method is actually supported or not, because we have expanded support iteratively in the past.
So there are different instructions based on whether they use bytes or ints. Is that what you're saying?
Right. So there are different instructions under the hood based on whether it's byte or int. But more concretely, we've had cases where we've had an API and we've only wanted to support it for a subset of types. And since we expand the types over time, it being generic means that we kind of have to add support for these methods whenever a new type is added. And so historically, we have just explicitly listed every type to make that simpler. Notably, there's no additional work required in the JIT. It's just IL metadata, and the trimmer will remove any of the IL that's actually unused.
So Steve, is the reason you were asking because we would tentatively approve all of the other overloads right now if they're needed, so that it doesn't have to come back to review?
I had, I guess, 3 purposes. 1, what you just said, save us future time. 2, I was genuinely curious to know why byte was special. And 3, wondering to what extent we cared about consistency here, which I think Tanner answered with more generally with the T question.
Yeah, we generally care about exposing the relevant APIs where we can. As soon as we start getting into users have to manually convert it to byte themselves to do the operation, you start getting into like endiness questions and all kinds of other things, which are massively complex for users to consider and understand in the context of intrinsics. Whereas if we expose the overloads, the JIT can just do it for you.
I think I'd basically be inclined to say let's go and implement what's on the screen, and then if we find a need for other types, we just go and add them all.
Okay.
With no additional review needed?
Yeah, just the same pattern multiplied out over the 11 other cases or however many there are.
Yep.
Yeah. So basically, it's all of them are approved, but let's add them as users need them.
Yeah.
And just to confirm that I don't see a vector.shuffle, so we don't need a vector.shuffle unsafe, right?
Right. So
okay.
Because vector the general issue is that vector is variable sized, and because it is variable sized, you cannot trivially create indices representing the shuffle.
Okay.
Particularly not as a constant. You're effectively restricted to only non-constant shuffling. And that is that's generally not a scenario that's easy to support or that you would want to support.
So it sounds like we are okay with the API as it's on the screen right now, unless I missed something.
I think the only thing that's missing there is the note that the same API for the other supported T is approved, but let's not add them until people have a concrete need for them. And I'll do the minimal effort to go around and look at the user requests that have come by, and see if there are concrete needs for the others.
Dun dun dun. It's the same one, right? Yep. And then this one, Jeremy.
Sure. So on Windows, we already have existing ways of opening either software keys that were saved on the system or in particular hardware keys, such as a key living in your TPM or on a smart card or whatever. But we don't have an equivalent way in Linux where we're using OpenSSL. But Linux or rather OpenSSL does actually have support for this. It's a little bit more complicated than what CNG has for Windows and what, okay, it's just differently complicated than what CAPI has for Windows. But basically it's external, or keys can be loaded by name from a plugin. The difficulty and the reason we have different suffixes here is pre-OpenSSL 3 has one kind of plugin model that currently still works in OpenSSL 3, but is marked as deprecated, so they might eventually get rid of it. And then there's a new kind of thing in OpenSSL 3. So the old ones are called engines, the new ones are called providers. And we've seen people, especially over the last year, be asking how they can easily load keys off of their TPM. And the answer would be you install the TPM provider, which is an exercise left to the reader, and then call open key from provider. Provider name would be TPM2, and then providers call the key names a URI because they tend to support a complicated, like you can tell the provider I'm opening something by handle, or I'm opening it by a file where I've saved all of my key parameters, or I'm, etc. So I matched the name that they did from the things. For engines, there's a separate method for opening a private key and opening a public key. I've not seen an engine that actually implements public key, but when this issue first came up, actually Jan Kodis observed that there's open private key and open public key on the engine, and said, if we're doing one, why don't we do the other at the same time? So that is the many words for these few words. And then the design, like with Windows, we would have you do CNG key.open, where you open a key by name, and we give you back a CNG key, which you then have to ask, or you have to turn into an RSA CNG or whatever. Similarly here, what we get back from this is the key handle from OpenSSL, and then you would have to use like the RSA OpenSSL constructor that takes one of these key handles to be able to do anything interesting with the key handle. Yeah.
Seems good to me. Nobody any questions?
I'm trying to find nits to pick here, but I'm having trouble. Okay, here's a nit to pick. Is there a reason that people might need to know which world they're in, so that they might need to know like the differences, or which of the APIs is needed for their scenarios? I'm kind of grasping at straws here to ask if like there's something that we need for the caller to learn about the ambient context.
Which kind of ambient context do you mean?
Things like maybe what version of OpenSSL you're writing on top of, though I guess you would probably know that from the application if you're calling this API anyway.
Yeah, so I mean the OpenSSL version, we already have that exposed as a static hanging off of, say, EVP key handle, with the disclaimer that, as with all version checks, really you should only be comparing it to be equal to something else. I mean, the idea with this is if you're p-invoking directly into OpenSSL, make sure that before you do any complicated interop with our system, that what we think the version we're talking to is and what you think the version you're talking to is are the same, so that they are going to interpret details behind pointers the same. This is particularly if you write, if you bind to libcrypto.so.3, but for whatever reason we loaded OpenSSL 1.1, like, we can pass pointers because they're just 64-bit numbers, but they won't mean anything sensible. But
sure, I mean, I missed it if you said it, but what do you do with the safe EVP key handle once you get one?
Assuming you know what algorithm it is, which is an exercise left to the reader, you pass it to something like new RSA OpenSSL. The problem is Windows has a very consistent way that they talk about algorithms, which is a string, and OpenSSL does not have a consistent way that they talk about algorithms. They used to consistently talk about them from a set of numbers called NIDs, but with the OpenSSL 3 model, they're moving away from NIDs because that requires core registration, and they're starting to move to strings, but I don't know that we want to emulate OpenSSL 3 behaviors on OpenSSL 1, so that detail is basically what you would do is you would try creating an RSA OpenSSL. That'll throw the key isn't an RSA key. Then you'd try ECDSA OpenSSL, and that'll throw. And then you'll say, well, those are the only two things I knew how to handle, so this key's no good to me. It's a trial. It's not great, but it is better than what we currently have, which requires that you write the way that you actually load these keys is non-obvious. This is hiding a lot of interesting work.
Okay. So basically, we basically do this rather than adding factories to all of the RSA and whatever else OpenSSL provider constructors.
Right. So if we put, open private key from engine on RSA OpenSSL, then that would throw for it can't find the engine, the engine can't find the key, or the key is not an RSA key. And inspecting OpenSSL exceptions on our platform is not great, especially because the codes will change from version to version. And so you're losing a lot of detail. By having it here as you get the handle, like, it'll tell you, oh, we opened a key, you have the key handle now. And then if you try creating it as an RSA, that's now very much this key does not represent RSA. So now you can move on to the trial file without repeating a bunch of work.
Is there anything we can do to convey information as part of the handle about what it works with?
I don't know of a way that will be consistent across all the versions of OpenSSL we dynamically support. So we'd have to write our own.
So basically, it's
interpretation
we're making something possible, but someone still has to have a lot of knowledge about what they're doing to know that it'll work.
Yeah, but that's this. I mean, it's not exactly the same on Windows,
I'm not
but
putting it down.
Yeah.
This is super niche corner case. We're making something possible that wasn't before.
It is.
And we just basically say dragons, and you need to know what you're doing.
Right. And if you look at the way that people use the CNG support that I'll just say predated me, so I don't have to justify it. If somebody calls CNG key.open, they're almost immediately just saying new RSA CNG of that key. Like they're just blind asserting that the named key they're going to open is an RSA key. And that would be the same here. You would just blind assert. And if you really supported dynamic algorithm types, then you would do the try to fall. And if we can do something better later, we can. But yes, this is making something from nearly impossible to possible.
Okay.
One last question. The other constructors have unsupported OS platform, Android browser, iOS, tvOS, Windows. Presumably those ones we need here as well.
Yeah, we should paint them with all the. Only works on Linux, and we don't have a platform for that, so it doesn't work everywhere else.
Yep.
Yeah.
I guess really it also works on FreeBSD and OpenBSD and NetBSD, and we don't really talk about those. So this doesn't work on Apple products or Windows OSs or Android.
Yeah, it's a bit unfortunate that that's where we are, but I guess that's where we are. So then here. Happiness for everyone?
Make it so.
Ship it.
All right, then I think we're at time. Thanks everyone, and then I see you on Tuesday. Maybe.
Yes. Oh, and daylight saving time
This weekend?
this weekend.
Oh no.
So if you look at APIReview.net and look at the calendar, we noticed this on Tuesday. Everything was shifted by an hour. So
Yay.
Cool.
Good tip.
Yes.
Right. Enjoy, gentlemen.
Mm-hmm.